Oh, it is? Oh, pretty.
So look at 2 and 2. Nice little ratio there.
Wait, you're wanting me to do both of your application problems for me?
You had 2 of each of those, I believe.
We had 6.
Oh, that's right. Okay. Not an 11.1 and 2 each was 10.3.
That's true.
Oh yeah, that was true.
You want me to do both of your application problems
Oh,
for
I
you?
thought we
Just call it like you see it, right? Yeah. Well, hell, let me consider that for a second, shall I?
Will you better, marginal cost be back under 11.2?
No, not better. With you?
Yeah.
Uh-huh. All right, let's look at number 5 on 11, no, sorry, demand on 11.1. Where the hell is it? Oh, 4,000 over the natural log of x plus 10. So this is P equals 4,000 over the natural log of x plus 10. Okay. Where P is the price per unit in dollars when X units are demanded. Find the rate of change of price with respect to number of units sold when 40 units are sold. Guess what, guys? It wants us to find P prime of 40. Right?
Mhm.
Not so bad. Right, Jake?
Yeah.
Yeah. Okay, so how do we do that? Anybody have any guesses? Yeah, we're gonna call this a quotient. So here's my U. Here's my V. What's U prime? 0. And what's V prime?
1 over x plus 10.
Yeah, 1 over x plus 10. Now plug and chug, folks. So P prime is gonna be U prime V. What's 0 times anything?
0.
Good. Minus U times V prime, so 4,000 times that, which is gonna be 4,000 over x plus 10. So this is U prime V minus U V prime over V squared. Natural log of x plus 10 quantity squared. Questions? Who overthought it? Well, yeah, but I'm not gonna do that. Cause you can do that.
Just put 40 in the x.
Yeah.
That's it?
Yeah.
So it'd be the same thing over 50. Like
Negative 4,000 over 50 divided by the natural log of 50 quantity squared. Don't overthink it, guys. You can do that. You don't need me for that. Right, Caitlin?
And that one for the.
Yeah, because the log will disappear, right?
Well, you'll get a number. You'll get a number. Once you do natural log of 50, whatever that answer is, you're gonna square that sucker.
And then that's the rate of change.
And that's it. That's your rate of change. From 40 to what, guys? We always go over by how many? 1. So from 40 to 41, right? Remember what's x in
Do
this?
you in your calculator, do you put the natural
That's
log?
right.
Yeah.
Yeah,
Yeah, okay.
yeah.
It's negative 5.23.
Yeah, so P is price per unit. So we're saying if we go from $40 per unit to $41 per unit, what's gonna happen to our demand?
Wait, so is it negative 5 point something?
Yeah.
Oh, sorry, no, I lied. Because we're moving X, right? So we're going over from 40 units to 41 units demanded. What would happen if demand increases? What is price usually doing at that point? It's decreasing, and that bears out, right, by this negative sign right here. You guys cool with this? Okay, so if we're changing quantity and we're increasing the quantity demanded, we're gonna have to lower the price to meet that increased demand. So far, so good? Okay. Marginal cost. I can hear you guys going, yes. Find the marginal cost when 200 units are produced and interpret your result. You guys are way overthinking this. Cost equals 1,500 plus 200 natural log of 2x plus 1. And it wanted us to find marginal cost when 200 units are produced. Okay? So let's go line by line. What's the derivative of 1500? Imperative, yeah, 0. 200 is gonna go along for the ride because it's a constant coefficient. What's the derivative of the natural log of u?
Wait, you said
Over
200
two
goes
X
along
plus
for
one.
why?
Because it's a constant coefficient
Of the log?
of the natural log. So 4x cubed becomes 12x squared. Did the 4 go away? Let me write that down. If y equals 4x cubed, y prime is 12x squared. Let me ask you again, did the 4 go away?
No.
No, it went along for the ride, right? It's not really 12x squared so much as it is 3 times 4, x to the 3 minus 1. The 4 drops down, it comes along for the ride. Well, guess what? So does this. 200 is gonna come along for the ride. So far, so good, guys? So then what do you do? Plug in 200 and interpret the resulting slope.
Nice.
Does it make sense? Okay, Marco and then Caitlin.
Can you go over real quick the derivative of the natural log? I
Oh.
should be right.
Yeah, absolutely. So this is essentially natural log of some function. Doesn't matter what the function is. Whatever the subject of that natural log is gonna be, when you take the derivative, it's gonna look like that.
Oh, okay.
Okay? So the derivative of the junk over the junk. Groovy? Caitlin.
I was just gonna say that the numerator on that is the derivative of the 2x plus 1.
Exactly. Perfect. What else?
So was that answer for like 40,400, or did I type it in completely wrong?
I don't know.
Anyone?
Type it
Bueller?
wrong.
Bueller?
Autumn says it's wrong.
Huh?
Autumn says it's wrong.
Like
What is it?
$1.
By like $1.
Like
What is
$1
$1?
for the cost of the 201st unit.
It's like $1 for the cost of the 201st unit.
Did you say that?
Sometimes I'm like a little kid, you guys. I have like weird humor. Sorry. Apparently.
Typing it in is wrong.
Okay. And then from there on, you guys can fill and chill, right? You can do parts B, C, and D. Anyone struggling on parts B, C, and D, or is it really just the derivative that you guys are getting hung up on? It's the derivative for all of you, or just most of you? Give me a thumb if it's the derivative that throws you. The rest is, you can do it. Okay. All right. 11.2. Let's look at number 5.
He was explaining it to you, right?
Yeah.
It's like,
Really wish I could
I
touch the
wasn't
board
paying
with a dry
entirely
towel, but
attention to
it
that
makes
too
my
much.
skin cringe.
trying to do something.
Number 5. Is that the one with 500?
Yeah.
1 minus e to the negative 0.1x? Okay. Consistent on my size of parentheses here. Okay. How many of you want to treat this like a product? None of you. How many of you want to distribute that 500 and see what happens?
I originally wanted to treat it as a product, so that.
What happens
I think
when
you
one
do
of your
distribute.
topics
But
is
now you
just
distribute,
one of
yeah.
your functions is just a constant, so u prime is gonna go away immediately, right? So what if I just distribute this? Then I would have y equals 500 minus 500 e to the negative 0.1x. So I'll let you guys stare at that for a second,
That makes sense.
okay? And now it looks a lot like the stuff we did over here, doesn't it? So talk me through it. If y equals e to the u, and y prime equals u prime e to the u, talk me through the derivative here. 500, you killed it, killer. Okay, So minus drop down so that you don't lose track of your signs. And then what's the derivative of my exponent up here? Negative 0.1. Negative times a negative is a positive. 500 comes along for the ride. And my original function. So here, in red, is my u prime. And here's my e to u, and somewhere in there I dropped a constant coefficient.
So it's just 50.
Okay? And remember, it doesn't matter what order you plug all that stuff in there because it's all multiplied. 4 times 3 is the same as 3 times 4. Doesn't matter what order you stick it. Just watch your signs. Okay?
So the constant coefficient, like, that's always in front of e or whatever, is always gonna come down.
Always gonna come along for the ride. If it's attached to a function, or a variable, it's now a constant coefficient. Yeah?
Why isn't u prime negative?
Ah, it was. So if I bring negative 0.1 down and I multiply here, I'm gonna get a positive sign, because negative times a negative gives me that positive. I'm just being really intentional about, can't believe I brought out the boardroom bingo, but I'm being really intentional about my signage here. Okay? Questions?
So simplify it's like this. 50.
How many of you guys have to sit in meetings where people use the word intentional? And it makes me want to like hurt someone. Being really intentional, you should be. Why is that even a thing? Everything you do, you should do with intention.
Throw in there.
Yeah, it just makes it sound like you're genuine, sincere, a go-getter. Yeah, you're with me, aren't you?
Yeah.
It makes it crazy.
Was that 29 or 5?
That was number 5. You're like, no, they get harder. They get harder. How many of you guys tried this stuff over the weekend? Oh, shit. I saw 5 hands go up. You guys have got to start doing your homework.
It made me very sad.
I'm telling you right now, because today we are literally done with everything we've done so far. And now we're starting over, going backwards. So you really need to know your derivatives in order to integrate. So you've got to know this stuff. So get on your homework, trust me. It's gonna be a world of hurt if you don't. Number 29. E to the 3x plus 4 to the 10th power. Only to the 10th power. I see something. What do I see? Yeah, I see an exponent, which makes the outside function a what?
Power.
Power. So we're gonna use d out dn, right?
Mhm.
Otherwise known as u prime. Well, no, let's go nu to the n minus 1 times u prime, let's be consistent. Okay, so on your tattoo, the second derivative, tattoo, Russell, 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 Russell. And memo, I owe you one. Or did you get a spare?
No,
You need one?
please.
Does anybody else need a tattoo?
No, sí, hopefully I get it today, but we'll see. Thank you.
Really? Anybody else? Tattoo? That's okay. All right. So globally, we're going to use the power rule. Locally, inside the power rule, we have e to the u. So when we come time to take dn, we're gonna have to employ e to the u. You guys ready? D out. And you're like, no, I'm not ready, but you're gonna do it anyway. D out, 10 junk to the 9th. That's D out. That's nu n minus 1.
Okay.
Now we peel. So now we're just looking at the stuff on the inside. We know the 4 is gonna go away. So what's the derivative of that become?
Just 3.
3,
Oh, 3e, 3x.
2x.
your tattoo guides everything you do here, guys. If globally this is a power rule, you're gonna use NU n minus 1 times U prime or D out DN, okay? When you get to U prime, you need to use e to the u to take the derivative of this term. So you're employing derivatives number 2 and 3 on your derivative sheet, on the tattoo.
So the 3x or 3e to 3x is the u prime.
Yeah,
Okay.
yeah. So globally we have NU to the n minus 1. Locally, this is my u on D out DN. When we get to DN, we're employing U prime E to U. So we have two different layers of U going on here, guys. We have the global U, which is this entire inside function, and we have a local U on this, just e to the 3x. You guys okay with this? All right. Kinda, sorta, not really?
Can you do another
Oh,
one?
hell no, talk to me.
Is that the answer?
Yeah,
That
That's
one
it.
was the first.
Can you do another one?
what?
Can you do another one?
Can I do another one? Oh yeah, psh, why not?
17.
No,
Like another
I'm done doing your homework for you today. I'll do problems like it though, on
one.
what?
Yeah, that'd be-
Problem like 17.
Or problem like this one. What's 17?
That's the hard one.
But you're not gonna like go over that.
How much am I back?
Oh,
Like all of it?
Oh, you're, I saw it.
Don't even try to taste it.
But what if my granny underwear are like sticking out? Oh, they are. That's bad. Shh. I saw that. Like, she's crazy. She's crazy. What about this one? Okay. So globally, this is D out DN. So my U, I'm gonna have 6U to the 7th, right? So I'm gonna have to take that derivative, and then I'm gonna have to do on DN, I'm gonna have to take the derivative using e to the u. So D out. Anyone wanna talk me through D out?
It's y jump.
Mm-hmm. Okay, that's D out. Now imagine peeling away those brackets and all you're left with is the inside. So let's go term by term. What's the derivative of this?
Negative 4x.
So what's the derivative of this? Start with your exponent. Negative 4x times 4 is negative 16x e to the negative 2x squared. You guys with me? What's the derivative of 8x?
Plus 8.
And we're done.
Will they be like that hard on that?
Why not?
That one on my
Could you
cheat
just
sheet.
multiply like the exponents first and then multiply by the leading coefficient?
Sort of, yeah, so remember, e to the u becomes u prime e to the u. So it's all about your u. Whatever your u is, take the derivative of it, and that's what this is. So if our u is negative 2x squared, that's gonna become negative 4x. And if I multiply
She
that
multiplies it through.
together, I get the negative 16x. So really what I'm doing is two steps here. I'm taking u prime here, and I'm multiplying it times my constant coefficient here. Ferris?
Wouldn't it be positive 16
No,
because of the negative 2 being squared at the top?
What's 2 times negative 2?
Oh, it's just, okay.
Negative 4x, right, times 4 gives me that negative
I
16.
thought we were just squaring minus.
Okay.
That's okay, that's
I
okay.
guess I don't understand why you're multiplying it by the leading coefficient.
Well, for the same reason I multiply by the leading coefficient over here. When I take the derivative of 4x cubed, I'm literally taking the exponent down. That's the operation for this, is n u to the n minus 1. Over here, the operation is u prime e to the u, and if there was a constant coefficient out here, guess what? That's a part of it. So 4 times negative 4x gives me that negative 16x. Just like 4 times 3 gives me 12 over there.
So the negative 2x squared is just taking that derivative and then just
Yeah.
multiplying.
And I'm just dropping it down, because that's what I'm told to do, guys. I am told that whatever this exponent is, I take its derivative and plunk it down in front and then rewrite the original function. That's it. That's all it is. I just saw the light bulb come on. How did that feel? Good, right? So again, negative 4x, plunk it down in front. What's negative 4x times 4?
So you're taking the derivative of the first exponent, then you're taking the derivative of the second exponent. Yeah? No?
There is no first exponent. You mean this?
No, I mean like.
Come on up. No, seriously, I don't bite. Come on up, Caitlin, point it to me. Save me time. Seriously, it's okay. Save me time. Then I don't have to be like, here, where? I don't know where.
Okay,
Here.
so you're taking the derivative here.
Yeah,
And then you're multiplying that by 4 because you're taking the derivative here.
right, because I'm taking, my goal is to take the derivative of this e to
So you're
the
just
u.
taking the derivative like as you go down.
Yeah.
Like,
I found the derivative here, and then I drive that derivative downtown.
okay, like
And
this is
multiply.
hypothetical, but like if there was an x here,
Mm.
would you be taking the derivative of that, then taking the derivative of that, then
Yes.
taking the derivative of that?
Yes, and we would go
That's
layer
what
by
I was
layer by
asking.
layer by layer.
Okay.
Yeah.
Awesome. But I'm not gonna do that to you guys,
Yes.
okay? The worst you may see is something like this.
So many derivatives.
If I had y equals 5e to the 3x squared plus 8 to the, let's say, 6th.
So then you basically do d out d in of the exponents?
Yes. Is it Mitch?
Yes, ma'am.
Hot damn. I'm learning you guys slowly but surely. We got like a good third of you down now. I don't know you. Who are you? Hi, Ty. Awesome. Ty. Wes. Ty. Russell, where the hell did you go? There you are. Okay, all right, I'm learning. So, Mitch, talk me through this. Y prime, let me just put the 5 out first. Times what?
6 to the jump
6 times jump to the what power?
to the 5th,
Good. Times what?
6x,
Wait, where e squared? 6x. Good. Times what?
e to the, all of the jump.
All that junk. That's right. So here's my constant coefficient, drops down. This is u prime. This is e to the u. On u prime, I did d out, d in. It's not gonna get any worse than that, guys.
You have to
Pretty
just
bad.
shoot it with 5.
Nah, I mean, yeah, eventually, but this is, I'm leaving it plain so you guys can see where the hell everything came from. Because apparently there was an issue over negative 16x. So, just gonna leave it all right there. Just leave it all out there for you. Does it make sense? What's the hardest part?
Why did you leave it as 5 times 6 instead of like 13?
So we didn't.
What did I say, guys?
But
No, it's
you're
okay,
trying to
Caitlin, you're
leave it
fine.
Simplified.
Yeah, I just said, sweetie, that I'm gonna leave it like this so that you guys can see where all the chunks came from, okay? It's okay. I'm like, ah, good times. No, really, I left it like this so you can see constant coefficient just drops, and then the rest of this is your U prime, okay?
So when you distribute, it would be 30 to the gun.
Yep, 30 jump to the 5th times 6x. We can make that 180x out front, couldn't we, guys? Because what do we have without exponents? We have 6x, 6, and 5. 5 times 6 is 30, times 6 is 180x.
Even though the 3x squared plus 8 is technically an exponent,
Yeah, you can't, I'm not combining this one, hon. I'm only taking the stuff that's got no exponents to tie it down, okay? So I'm taking the 6x, and I'm bringing it out front, and I'm multiplying it times 30. So let me rewrite this. We're doing it now. Equals 180x, 3x squared plus 8 to the 5th, e to the 3x squared plus 8 to the 6th power. Okay? And once again, I'm being very cautious, you guys. Base level, exponent level, exponent of exponent level. Do you see how I'm being very careful about writing this? Hi, Brenda. Does it make sense?
I'm confused on the 6x part.
Yeah.
Like after the 3x squared plus 8 to the 5th, that's
Just
6x
the
right
I
now?
want you to ignore this.
Okay.
That's what I have not covered is U. What's U prime? Help out him, guys.
it's 2 times 3 and then 8 drops, so it's 6x.
Oh, okay.
Yeah, so that's the DN from D out DN.
But
Never
like,
mind, okay, no, never mind, I'm
That's
just
okay.
really,
but like I
There's a
was
lot.
saying
Yeah,
over there,
long
you took
weekend, okay, I
derivative.
understand.
You took the derivative of the exponents first, so you put the 6 times
The whole
one that's
thing.
in front of there.
Yeah.
And then the jump, and then the derivative, but then you also did that times 5.
I did.
So you took the derivative and you took the derivative.
Mhm. This is a nested function. Once again, guys, globally it's e to the u, so we use u prime e to the u to define our behavior. Locally on u, this is a power. So you have to use the power rule to take its derivative. That's what all of this is. You guys with me? Okay. All right. So now I want you to get it out of your heads that we're doing derivatives. Wipe your slate clean.
This is not a competition.
If only that was for real.
I'm like,
You're really
If only, right?
really competing with me.
Yeah.
you're putting so much work in it. It's just like, you did more. I mean, you did. It was just, yeah.
It's like you're competing.
It'll make us better.
Okay.
Okay. Like, just saying.
Oh, God, that was so hard. I'm literally like scrubbing with all my might. And this stuff is barely shifting. Boy, okay. Today, we're going to learn about indefinite integration. So everyone should have their tattoo out. Okay. I had a handful of them, and I asked who needed
I know, I
one.
thought I had them, but I guess. Sorry.
And those patients are sleeping.
Does anyone else need a tattoo? Anybody? Okay, all right. Let's do this. I want you guys to think of the first in the set of derivatives on your tattoo and the first in your set of integrals as a paired group. Okay? So let me show you what I'm talking about. Y equals 6x cubed plus 10x minus 5. What's the derivative of that?
18x squared plus 10.
rewrite this. And I want you guys to just watch me for now. There will be time to write it down in a second. Y prime is the same as saying the derivative of y with respect to x. I don't put it very often on the board, but it means that. You guys know that, right? Okay, so instead of y prime, I'm going to use dy dx. So dy dx equals 18x squared plus 10. Now that dx is a command. The d on top is a derivative. So this is like saying the derivative of y with respect to x. I'm going to multiply both sides by dx. And what happens to the dx's over here?
Cancels out.
They cancel. So what I'm left with is dy equals 18x squared plus 10 with respect to x. Okay? Is everyone cool with that? Because what we do to one side of the equation, we do to the other. That's what equations are all about. They're equal opportunity. So what I do, Blaine, I totally forgot you before, and I just remembered. Are you good? You want to find me after for a couple minutes? Whatever it was? Or did I get it? Are you sure? I'm sorry. Okay. All right. I'm going to do the same thing again. Whatever I do to one side, I'm going to do to the next. Who's laughing? This is a new command. It means integrate with respect to y. Integrate this stuff with respect to x. So I'm going to rewrite this. If I integrate 1 with respect to y, what I get on this side is y. Okay? And if I integrate all of this stuff, I'm going to change the color of the dx just for a second. Because I want you guys to understand that integrate some stuff with respect to x is a command. Integrate the stuff with respect to x. WRT means with respect to. You guys should have seen that once or twice in my handouts. Okay? So this is a command. Integrate some stuff with respect to x. Now,
What is WRT?
with respect to x. So now I've got some stuff I need to integrate, don't I?
Is this 11.3?
Nope, this is 12.1. This semester I'm calling it integration in a shortcut. I want you guys to take a look at the integral, the first integral on your tattoo. And I want you to notice there are steps tied to the integrals. When you are on integral number 1, there are no u's in that integral. It's the integral of x to the n power. There are no u's. Do you guys see that? So all of the steps that are about u, find u, create u prime, we want, make it look like the template, perform integral. You can ignore all of those. You go step 1 to step 5. You make it pretty, and then you perform your integral. So we need to get this into a form, and it already is, but we need to get this into a form that looks like this. The integral of x to the n with respect to x equals x to the n plus 1 over n plus 1 plus k, and n cannot be negative 1. So let's just look at this for a second. Why can't n be negative 1? It makes the denominator of your answer 0, and can we do that? No. So you should never have a negative 1 up here as your n, okay? Should never be a negative 1. If it is, then we default to the natural log, but we'll get to that later. All right? So all we have to do is make it pretty, get it into this form, just like we did to take derivatives. We're gonna make it pretty, and then we're gonna integrate. So let's look at this first term. What's my n on this term? It's 2. So what's n plus 1 gonna be? Yeah. What's my n over here? You guys remember that? There's actually an x to the 0 there. So what's my n? 0. So what's n plus 1? Yeah. So my n plus 1 is going to be 1. You guys ready to integrate?
No. What's the n?
N is your exponent. And look at your tattoo.
Oh,
Look at the pattern. So this is all about pattern recognition, right, guys? Once we figure out what the pattern looks like, then we just perform the steps. So if I've got some x to some power, that power is now my n. Now I'm gonna fill it in. 18 goes along for the ride, Caitlin, because it's a constant coefficient. X.
Wait, how do you know to put like the n plus 1 on both of those? You just do that to anywhere there's an x?
Because I know that every term that's x to the n is gonna end up in this form. So whatever the power is, I'm gonna add 1 to it. And then I'll tell you guys why it works the way it works. So just hang tight, okay? This is why I didn't want you guys to write this down. I wanted you to just to watch me. Okay? So I have 18x to what power? What's n plus 1 gonna be? 3. And I divide by 3 because that's what the pattern tells me to do. And this becomes 10x to the 1 over 1 plus some constant. So let me rewrite this. Y equals, what's 18 divided by 3?
6.
6x cubed, and 10 divided by 1 is? Is that what I started with? Way back there at the beginning?
Darn near close.
What's the difference?
-5 versus +k.
The k. Remember I said you kill the constant, you kill it, killer?
Yep.
Right? K for killer? Guess what? It's not dead. It's a zombie. You just revived it. That -5 that you killed is now back to life in the form of k. Because when we took the derivative, we slashed it, we killed it, but now we have to account for it. It's time to pay the piper. Yeah, so we have to account for it. Now, let me talk to you guys about why this system works. The mechanics of taking the derivative were ax to the n becomes anx to the n minus 1. So what did we do here? This term got what? A and n get what? Multiplied. How do we undo multiplication? Division, right here. We subtracted 1 from the derivative, or from the exponent. How do we undo subtraction of 1? We add 1. That's what this stuff is. Division and addition instead of multiplication and subtraction. We are just undoing what we did. You guys cool with that?
Yeah.
If you ever need to know if you're right, take the derivative of your answer, and if it looks like the thing that you were asked to integrate, you're good to go, aren't you? Because f of x, not f prime, f of x equals the integral of its derivative with respect to x, doesn't it? If we take that derivative and we integrate it, we're gonna end up back where we were supposed to have started.
So how do we find out the k?
We'll get to that.
Okay.
It's a great question. We'll get there. We'll get to there. Right? You guys ready?
You said don't write this down now, but does that mean you're gonna like give us steps or something?
Oh yeah, on the handout, I talked to you guys about it, and my notes are probably prettier than whatever's on here. So let me just hand out the notes right now.
Friendly competition. It'll make me better. I bet because of that, I'll get the highest grade.
Awesome. This pile back here is just 2, 5, 8 people. Yeah, make sure everybody in that little knot of people gets one. Thank you. And then I have
Hieroglyphics.
2, 4, 6, 7, not hieroglyphics. You don't want it to be hieroglyphics. And then 2, 4, 6, 7.
So is that y or y prime, or like that? Or,
When we integrate, we're going back to the original function. So we're undoing the derivative. This is y prime, right here. We're undoing it so that we can get back to the original function. You want a visual representation? Look at your tattoo at the very top. The process to get from revenue, Autumn, the process to get from revenue to marginal revenue is the derivative. If you want to go backwards, you're going to integrate marginal revenue to get to revenue. Okay? So that's what that other side is. We're just completing that circle. We just go round and round and round in this class. Blaine.
I was gonna say, I know we'll see it in homework, but, what is an application of that?
Oh, we will. Let me get through the mechanics and get you guys solid on the mechanics, and then I'll talk you through the application. Because we are going to spend time on an application today for that very reason. Because it doesn't look like anything else you guys have done. Deep breath, you guys. I've got you. I really do. This is the crappiest. So hard to erase. I shouldn't have forgotten my eraser day. That's actually the thing I'm saddest about not having from
Very
my
nice
bag
video.
is a damn eraser. Imagine that. Okay, let's try another one. Y equals the integral of 4 over x cubed plus 10x minus 18. And we're going to integrate all of that with respect to x. Just like when we took derivatives, we need to make every term pretty. Is this pretty? Can I make it pretty? How?
Bring the x to the negative third to the top.
That's right. So let me write this in here. Y
Bring it
equals,
uptown.
bring it uptown, and when it crosses the line, it changes the sign. Okay, so here's our template, which is on your tattoo. So we're gonna rewrite this as the integral of 4x to the what power? Negative 3. Plus, go ahead and give your 10x a power. It's positive 1. Just so you can see the powers written down. Minus 18x to the 0. So we're doing this so we can see our n's on everything. And now I'm going to go through and ask myself, what's n plus 1 going to be here for this first term? Negative 2. What's 1 plus 1 here? N plus 1 equals 2. And what's 0 plus 1? 1. So those are going to be our new n plus 1s on this format. Wait,
What allowed you to add an x to negative 18?
nothing. Algebra. What's x to the 0th power? What's anything to the 0th power? Yeah, what's 1 times that constant? Yeah, so there's secretly an x to the 0 just landing there. Just like we had 18x before becomes 18. The reason is it's 1 times 18x to the 1 minus 1 equals 18x to the 0, right? Which is just 18, okay? So there's that hidden x to the 0 there. What's my integral, guys? Don't overthink it.
4x to the negative 2 divided by negative 2.
Good?
10x to the sec, yeah, 2 over 2. And then, yeah, that over 1. You got it. Plus, okay. Yeah.
will ding you if you don't have a K. So don't forget your K. You have to account for those constants. In this case, what was our constant? We don't know, do we? Because we were just given the derivative, so we have no idea what the original function was. But how do we check our work? If we took the derivative of this, where should we end up?
Back and start.
Right here. Chandelier.
Is the K always positive?
Isn't what?
The K, is it always positive?
Nah, K can be anything. It could be 0, it could be negative 10 million, it could be 50,000, it could be e to the second power. All of those are constants.
When we put it, do we have to put like plus K or can it be also minus K?
It could be minus K,
Okay.
because K could be negative, making it positive.
Okay.
Yeah, you can make it minus K if you want, but watch your signs, because that might eat you alive, okay?
So that's why there's no like simplified amount or anything?
Well, I mean, yeah, what's 4 divided by negative 2? Yeah, so y equals negative 2x to the negative 2 plus 5x squared minus 18x plus k, and that's your simplified version.
And then now you take the
Adam?
derivative.
Was
What?
one on the left supposed, that negative 18 supposed to have an x, or did you just like add an x when you did the one next shade add an x?
I put x to the 0 in here to show you guys that there is actually an right now, and it's 0.
Where,
0 plus 1 is 1.
But like, I don't know, I'm just confused, because there's no x over there, and now there's an x.
Right,
Well, there's always an x
Okay.
and a 0, like,
I just did this on the board.
Oh.
So 18x, the derivative of that is 18, but it's not really. It's 1 comes down times 18, x to the 1 minus 1. And you get 18x to the 0. X to the 0 is just 1, but it's still there. I'm just rewriting 1 in a form that I understand so that I can add 1 to it,
Okay.
okay? Who else? I saw another hand. Autumn.
where does the dx go? I'm like reading the notes, it says command integrated with respect to x.
It's a command, so once you've done the command, do you need the command anymore?
No.
Think of it as a checklist. So once you've done it, notice that my integral thing with respect to x disappears when I've actually integrated. You guys with me?
So those are like the same
Yeah,
thing or something?
yeah.
Okay.
Let's do another.
Let's do it.
I don't want to touch the dry one, but I'm gonna. No, I can't. I can't do it.
You want me to erase your board for you?
Just don't make fun of me today, guys. It's been a day. Shut up. I recognize how dumb this looks. Just go with it, okay? If this had been day 1, you guys would have been laughing so hard, but not out loud. Now you know you're safe and you can laugh at me out loud.
You dropped something,
At least it wasn't toilet paper. Oh, you're gone. Katie Senga, Department of Chemistry. Academic coordinator. I know why I need that. Okay, all right, how about this one?
Weird.
You got a warning somewhere, I'm really hoping that I like.
Oh, yeah.
Oh, come on, it's not that bad.
They probably would give you a ticket this time.
Now I can scrub it.
Okay, well, then you're okay then.
Over to where you guys work on that.
They gave me a warning a long time ago too.
Is it pretty? Can you make it pretty?
Just check when you get.
Yeah.
And if one gets
So,
involved really fast.
3 over x to the 1/2 with respect to x equals the integral of 3x to the negative 1/2 with respect to x. What's your n now? You guys remember the cheat? We did top minus bottom. Do you guys want to hazard a guess as to what the cheat is when you're adding one?
Bottom plus top.
Yeah, it's top plus bottom. So what's negative 1 plus 2? denominator stays the same. So negative 1/2 plus 1 equals negative 1 plus 2 equals 1. Denominator stays the same. So now we're adding instead of subtracting. So what's my integral? Be careful about numerators, denominators, multiplication, fractions. Told you guys this is why we're going back to kindergarten. And learning how to write base layer, exponent, exponent of exponent, denominator. So what's my integral? 3x to the 1/2 divided by plus k. How many of you know how to resolve that? Copy dot flip? Is that one way to, that's one way to say invert and multiply, right?
Yeah.
Okay, copy dot flip. Okay, I also like donuts. Does anybody else out there like donuts?
Yeah,
Yes,
especially bougie.
the grape donut.
3x to the 1/2 actually has a denominator.
Oh my gosh.
And if you think this is making it worse, hang tight. Draw a little donut. So where does this go? On the bottom? And where does this 2 go? On the top. You guys with me? So she's like, God, no, what the hell is that? Where did I lose you?
Why is she talking about those?
The whole fraction part?
Uh,
That's okay. Copy dot flip, is that how you guys learned it? How many of you?
Copy dot floppy.
Okay, how many of you guys learned invert and multiply? Okay, we're old. Yeah. What I'm doing here, guys, is I'm inverting this 1/2 and making it 2 divided by 1 times 3x to the 1/2 divided by 1 plus k. So then what do I get? 2 times 3 equals what? 6. Equals 6x to the 1/2 plus k. How do I check my work? Take the derivative. So what's 6 divided by 2? 3x to the what? Negative 1/2. Is that where we started?
Yeah.
Basically, right? We're just going backwards, guys. Autumn, talk to me.
I just did a lot of them.
Okay. Memo?
So how did the negative 1/2 turn into a positive 1/2?
I added 1 to it.
Oh,
My negative 1/2 was my n. If I add 1 to it, it becomes positive 1/2.
okay.
Okay?
So in this case, you would want our answer to be that, like, final answer over there, not this unsimplified one over here.
Yeah, no, in this case, it's much nicer to go ahead and do this, especially if you want to take a derivative to test your work. It's much nicer to have a simplified version. Ryan,
Is this the shortcut? Or have we not?
this is it. This is it.
'Cause I know
Make it
that
pretty,
there's-
integrate.
Yeah.
Make it pretty, integrate. Make it pretty, integrate.
So it's
Make it
y
pretty, integrate.
equals 6x.
Mhm. Yep. One more, and then we'll do an application problem. Pick one out of the book. Like the hardest integral I can find. So that you guys see what you're looking at, right? I mean, which is worse, me putting hard ones on the board and you finding that your homework is easier, or me putting easy ones on the board and you going in and discovering?
I don't like
We
that.
go to, or do our homework.
It seems like that
and
happens
the
often.
problems are like
I don't know,
not.
like that.
What?
I like that. Don't do that.
Yeah, no. It's always like easier than the homework, and then the homework's like.
You might have this.
Yeah, it's like, except the accounting's like 100 times worse.
Okay, let's do this one.
That teacher sucks.
This is 28 out of your textbook. So we're integrating, wow, I can feel a breeze, like that whole thing must be open, huh? 3x at good times, 3x to the 8 plus 4 over x to the 8 minus 5 over the 5th root of x with with respect to x.
That's,
That's what you're talking about?
yeah.
Is that what you wanted to see? Is it
Yeah.
pretty?
All that is
It's
making.
ugly as hell.
Yeah, it's just making stuff pretty. That's what we did when we did the shortcut, right? We just made it pretty and then we took the derivative.
Okay, I'm just a little confused on like what this all means, like 6x to the 1/2 plus k,
Mhm.
and then 3 over straight x, like, what does that mean?
This is the derivative of y. So we're integrating y prime. What we're doing here is we're integrating y prime with respect to x. And when we integrate, we're moving backwards. So remember, when we go from y to y prime, we take the derivative. If we go from y prime to y, we're
But yeah,
integrating.
it's still gonna have all that stuff.
It's how we go from y prime to its original function. Pretty? Awesome. Okay, is it pretty, guys? Can we make it pretty? Yeah, sure. How about that first term, is it good? Yeah, it's an x to the n form. How about this one?
Minus 4x.
And then negative 8.
So plus 4x to the negative 8. And I'm gonna do a half step on this one. So this would be minus 5 over x to what power, guys? 1/5. And so when we bring that up and change the sign, negative 5x to the negative 1/5. Is everyone cool with this? I said they weren't going away, I meant it. Hopefully you're comfortable with these by this time, because we did them for a long time in chapter 9. What's my integral? Don't overthink it. What's n plus 1 here?
9.
Good, so this becomes, whoops, I don't need that anymore. Because I'm integrating. I don't need the command because I'm about to do it. So this becomes 3x to the 9 over 9, right? Plus 4x to the what?
Plus 1.
Yeah, okay, groovy. Minus 5x to the what?
4/5
Yeah, over
over 4/5.
plus k. Now we simplify. 3 divided by 9 simplifies to what?
Third x, no.
Yeah, so x to the 9 over 3, or 1/3 x times x to the 9th, good. And this becomes negative 4/7 x to the negative 7. I'm gonna multiply 5 times 5 is 25 fourths, x to the 4/5 plus
Leave
k.
that last part over
What, where?
the negative 25.
Oh, yeah, so this is gonna,
It's gonna be a 6 at the bottom.
a 6? Where?
Or
No,
Copies out.
You did the. you
it'll be
did the donut
6.25. 6.25. What?
You did the donut thing.
I did the
of
donut thing.
Multiplying 5 by 5.
Yep, so the 4 is gonna end up on the denominator and the 5 is gonna end up on top. I built a little donut.
Just
Half a
to
donut.
clarify, the 4/7 is the fraction, the x is not a part, it's not like
Oh, it's part of it.
4x on the top over 7, or is it the same?
Is this the, oh God, sorry, my
Do
brain.
47, you did.
I could do 47. How about 4x over 3? Is that the same as 4/3 times x, guys?
Yeah.
Yeah, why is that? Because this is like saying 4/3 times x over 1. Right? So 4x over 3, same thing. Okay, Ferris, where'd I lose you?
sure, I figured
Okay.
out where I was
6.25?
going.
Yeah.
Is there ever a time when there's not a K
No,
at the end?
no. There's always a k, even if it's 0, you have to account for that constant. Now let's talk about where to find that constant. You guys ready? It's that time.
Slash out the k value for the constant, so you're
Is
just
this
bringing
still
it
part of the,
because we're just.
Go ahead.
is finding the A a part of 12?
Yeah. Oh, yeah.
So.
This, right here.
You went to 0.
So what's 3 divided by 9? It's the same as 1 divided by 3. So I just simplified it.
Okay.
Does that make sense?
Yeah, that would be good.
Okay, you guys. Let's talk about
Okay.
what that K is. That K,
And the denominator, right?
That's your answer, Stephanie. You just do.
that K is an unknown. So let me talk you guys through a problem and see if you can follow along with me. Let's do a revenue problem. Marginal revenue in dollars per unit per month is given by the following function. Marginal revenue equals negative 0.006 x plus 36. And we're asked to find the total revenue from the sale of 75 units. There is going to be a point where I have 3 unknowns in the problem. For example, this is actually equal to y, isn't it? How many unknowns do I have in this problem?
4.
X, Y, K. I have 3 unknowns. So how do I solve for one unknown? I need to know values for the other 2 things, right? That's basic math. In order to solve for one thing, I need values for everything else. Groovy? So there is a revenue, what I like to call nugget, that is true always. It is always true. And this comes from the concepts of business, or the basics of business in the concept of this class, or context of this class. And you guys might see something that looks really familiar to you. What's this point right here?
0.
It's not just 0, it's 0, 0. So we're saying when production is 0, when you build nothing, right? How much money can you bring in? So when you build nothing, x equals 0, you bring nothing, revenue equals 0. You guys with me? Those are values for our 2 unknowns so we can solve for K. You guys with me? We have to know 2 values. We call them initial conditions in math. I just call it your nugget. It's your little nugget of information. And with revenue, they will not be explicit. In other problems, they will be. So let's go ahead and integrate this sucker. Revenue is the integral of negative 0.006x plus 36 with respect to x. So what's my revenue function going to be? Negative 0.006x to the what power? 2 divided by 2 plus 36x, right?
Plus
36 plus, and now I'm going to give it a sub r, k sub r, constant associated with revenue. Because let's say you're doing this with revenue and cost. So you'll have a constant associated with revenue, a constant associated with cost. Excuse me, this could get really complicated, right? So label everything. I'm going to set revenue equal to 0. I'm going to set x equal to 0. And I'm going to solve for k sub r. So to solve, because this is an incomplete function, I cannot just start plugging crap into this because I don't know what k is. So now I say 0 equals negative 0.003x squared. Well, that should be a 0. Plus 30, no. That's okay, fair.
You said set y, you're gonna set y to 0, and then you're also gonna set x to Oh, you're doing the same thing.
Yep, I'm gonna do it all at once. So what's left?
J,
And what does it equal?
0.
Okay. In this case of r equals 0, so my real revenue function is going to be negative 0.003x squared plus 36x. Can I do that every time?
Yeah.
Can I assume that k is always gonna be 0? No, otherwise why bother, right? Why bother with it? K will not always be 0.
Because there might be something without an X.
Right, because what this is truly about, guys, is making this statement true. It's not about this so much as it's about making this true. Something has to get added to all this to equal 0. In this case, 0 gets added to all this to equal 0. But that won't always be the case. Sometimes this is some non-zero amount, and you'll have to figure out what to add to it to make this true. You guys with me?
So would that be if that point wasn't 0, 0? Like we're not given that point?
Yeah, but, okay, so all revenue looks like this. Always, 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 always. It always starts at 0, 0.
Yeah.
Okay? K is not associated with 0, 0. All we're doing is we're giving a value at a point on our revenue so that we can find the constant associated with that revenue function.
And
Okay.
it won't always be 0.
It will not
Zero.
always be 0. Exactly.
Plugging 0, 0.
Yes.
You're always gonna plug 0, 0 in, but it might be.
For revenue, you're always gonna plug 0, 0 in, but let's talk about a different problem. So at this point, you can plug your 75 in and get your answer, right?
Not sure.
Let's look at a different one. So I want you guys to be solid. We're gonna go all the way to the end, so hang tight. I know you're getting antsy. We have 5 minutes. We're gonna use every moment. Ugh. I wish I could just etch a sketch this thing. Just press a button and have it just blank itself out. That'd be great. Oh wait, that's a smart board. You guys should complain to AHAC. They don't listen to us. Okay. Average cost. I'm gonna do this to you guys. The DeWitt Company has found that the rate of change of its average cost is 1/4 minus 100 over x squared. Okay? The average cost of producing 20 units is $40. That's my nugget, guys. Average cost is C bar of X. 20 units is X equals 20. And C bar of X equals $40 when X equals 20. That's my nugget. So now I have a value for C bar. I have a value for X. Now I can solve for K. You guys ready? So let's make this pretty. Average cost equals the integral of 1/4 minus 100 x to the -2, all with respect to x. So the integral of that is going to be 1/4 x minus 100 x to the -1 over -1 plus k sub c bar. The math isn't that hard. It's remembering what to do with it that's hard. Is everyone okay with where this came from?
Where did that come from?
Which part?
What you're pointing to?
This guy?
Uh-huh.
So n is -2, so n plus 1 is going to be -1,
Oh, okay.
right? So n to the -1, -1.
Okay.
Or sorry, n plus 1, n plus 1.
Oh, okay, okay.
Groovy? So let me make this pretty. C bar equals 1/4 X plus 100 over X plus K sub C bar. So all I did was I resolved that negative into a positive, and I dropped my X downtown and changed the sign. So now I'm gonna set X equal to 20 and C bar equal to 40. Here we go. 40 equals 20 over 4 plus 100 over 20 plus K sub C bar. Now do you guys see why this becomes important? Gesundheit. What's 20 divided by 4? What's 100 divided by 20?
50, or sorry,
5. So 5 plus 5 is, and 10 plus what equals 40? 30. K sub C bar equals 30, and if you do the math, you'll see it. So now my true cost function, or average cost function, is gonna be C bar equals X divided by 4 plus 100 divided by X plus 30. Yes, Adam, and then Caitlin.
For the, oh wait, actually, never mind, I just stopped that. Never mind.
Do you see it?
Yep,
Caitlin.
that's it.
I thought I caught a mistake, but I didn't.
You what?
I thought I caught a mistake, but I didn't.
Oh, darn. Anyone else? That ate our entire day, but does it make a little sense?
Yeah.
For you, but what about the rest of you guys?
Like even 100 divided by 20 would be 5, 20 divided by 4 would be 5.
40 might be.
Okay? So you guys have the handout? Are they helping? Okay, good. Keep trying them. Here's your homework. I know, right? You just thought you could get away with it. 12.1. I would like you guys to please do 5 through 28 every other odd. Revenue times 2. So there are 2 odd revenue functions, please do them both. Okay. And pollution. I did your average cost